Review video for question 7. Here we're looking at the same problem that we were in problem 6. So we had the joint probability mass function that was given to us here. So this is our sort of f of x, y is given in this table. And we're going to find the conditional probability mass function of y given that x is equal to 3. Now I'm going to need to use my my marginal distributions to do this. So we'll throw those in here for a minute too at times. So our conditional probability mass function of y given that x is equal to 3. So when we are finding, we've got trying to have like our distribution of y, so we're going to have all the different possible values of y. Y can take the value 0, 1, 2, 3, 4, and 5, remember? And we're going to be finding the conditional probability mass function, sort of f of y given that x is equal to 3. So what we're going to be doing is looking at f of 3y divided by the marginal probability that x is equal to 3. That's what we're going to be sort of putting in here. So looking at what we did last time, we can see our marginal probability that that x is equal to 3 is 0.125. So this is going to be our f of 3y divided by 0.125 as I go through. And so as I look with sort of like, okay, so x is equal to 3. So the probability that y is equal to 0 in this situation is 0. So when I divide that by 0.125, I still get 0. The probability that I have 3 and then 1 is also 0, so that one's 0. 3 and 2 is 0. 3 and 3, the probability is 0.03125, but I need to divide that by the probability that x is equal to 3. And so that gives me a probability of 1/4, or 0.25. Probability of x being equal to 3 and y being equal to 4 is 0.0625. To find the conditional, I divide by probability that x is equal to 3, which is going to give me 1/2, or 0.5. And finally, the probability that y is equal to 5 in this this conditional distribution with x equal 3 is the joint probability here of 3, 5, 0.03125 divided by the marginal probability that x is equal to 3, 0.125, which again gives me 1/4, or 0.25. So this is my conditional distribution of y given that x is equal to 3. Now, next thing I want to do is find the mean of y given that x is equal to 3. So to find the mean of y given that x is equal to 3, I'm going to come through and we say, okay, mean of y given that x is equal to 3. I'm going to use this conditional distribution, and I'm going to add up over all the different possible values of y. I'm going to add up y times my conditional distribution's probability. So essentially I'm taking 3 times 0.25 plus 4 times 0.5 plus 5 times 0.25, and that gives me my conditional mean equal to 4. Part C asks me to find the variance of y given that x is equal to 3. To do this, I am going to find the expected value of y squared, given that x is equal to 3. And to do that, I'm just going to take y squared times this conditional probability, given that x is equal to 3 of y. So that's going to give me 3 squared times 0.25 plus 4 squared times 0.5 plus 5 squared times 0.25. And so my expected value of y squared is going to be 16.5, which means that my variance of y, given that x is equal to 3, is going to be this expected value squared, expected value of y squared, sorry, minus the mean squared, which gives me 0.5. So there's parts B and C. Part D asks to find the conditional probability mass function of y given that, of x, given that y is equal to 4. So again, I'm working with this distribution. I'm going to say okay. I've got to take x, and I'm going to be looking for the probability that x takes on that value given that y is equal to 4. Now I know this is going to be the probability of x of y divided by the probability that y is equal to 4. And the probability that y is equal to 4 I found way back with my marginal distribution of y is 0.15625. So I'm going to be dividing by 0.15625 f of xy. Sorry, f of x4. Okay, so values of x can take on 0, 1, 2, 3. When y is equal to 4, the probability of 0, 4 is 0. The probability of 1, 4 is 0. The probability of 2, 4 is 0.09375. I have to divide that by the probability that y is equal to 4, 0.15625. That gives me 0.6. And the probability of 3, 4 is 0.0625 divided by 0.15625 gives me 0.4. So here's my conditional distribution. And then the last part, E, asks me to find the mean of x given that y is equal to 4. Mean of x given that y equals 4. Here again I'm going to take each of these values and multiply it by its conditional probability. So I'm going to have 2 times 0.6 plus 3 times 0.4. Same process that I did with the conditional distribution of y given x just a minute ago. And that is going to give me a conditional mean of 2.4. And that is the end of question 7.